Right, a real quick fast forward lesson recap here. So we're going to do sine waves, properties of a sine wave. Let's fly through this together. So a sinusoidal wave, that's what you're looking at here on the screen on here. We're going to go through the properties of a sine wave now and what it means. So a sinusoidal waveform is used to represent one cycle of an alternating voltage or current. Remember, an alternating voltage or current is it's alternating between positive and negative. That's why it's going positive down to negative. That's an alternating current. Okay? Right. So the coil in a simple electrical alternator rotates 360 degrees. That's what you're going to see in the next few slides, is this rotation of this alternator and how that affects the AC voltage going from positive to negative. And the output voltage rises steadily from 0 volts to the peak value. So it rises from 0 to this peak value in the positive and then goes down to the negative peak here. Peak value, peak value. We'll go through these. Then falls again to 0 volts and repeats the cycle in the opposite direction. So when it says polarity, it means it's going between negative and positive like that. Okay. So this action is demonstrated in the following animation where the movement of the coil is plotted in 15-degree increments. So you're going to see next, you're going to see me plotting this on a graph as it goes. As this spins round the alternator, each 15-degree increment, it's going to show how this works on the graph. Okay, so let's do it. Let's mark it as we go. So we start off. We see the coil start rotating round, and then it reaches its peak value. At 90 degrees there, it reaches its positive peak value. Positive, negative, remember. And then just while we're on this slide now, let's do this. So this represents the time, and this upward axis here represents the voltage. So let's continue. So it comes back down. When it reaches 180, like we say there, 180 degrees, it's back at 0 volts. So let's continue. And when we hit down at 270 degrees, which is down at the bottom here, we get the negative peak. So remember, I'll just say it again, that was the positive peak there. This is the negative peak there. Okay. Comes back up to 360. That's one full cycle from there to there. So when it's gone from 0 degrees in, and it's gone up to the positive peak, down to the negative peak, and back to 0 degrees there. Okay. So the properties of a sine wave, what we've just been talking about, I've just been saying this without really explaining it, peak value and peak to peak. If you look at this, we'll look at the same thing again, aren't we? So we're looking at, this is the negative peak value here. And this up here, you see this arrow saying peak value, saying that this is the peak value on the positive side. So when the AC current is going from positive to negative, and it's just going positive, negative, like that, like we just showed on the graph before, and that this one cycle, the peak value is this value up here on the positive side, and the peak value on this side is, on the negative side, is this value. And the peak to peak is the difference between, you see the peak on the negative and the peak on the positive, that's the peak to peak value. Right, okay. And then we've got two more things to talk about here. We'll go into more detail about these on another slideshow which I've got. But if we look, we've got the RMS value, the root mean squared value. And if you look on here, so that's represented by this red dotted line here. And that's going to be the peak value times 7.07. And basically what we're saying there is that the RMS is equal to 70.7% of the peak value. Okay? So that's why we do 0.707 times peak. So we get that peak value at the top and we multiply it by 0.707. And then the same thing applies to this average value, but just it's an average one instead. So instead of being 707, for the average value on here, this black dotted line, we're going to do 0.636 times the peak. So we'd get this, let's say it's on this side, so we'd get this negative peak value here, this one, okay? And we'd multiply that by 0.636, and that's going to equal the average value. Right. And remember, just while we're on here, this basically is saying that 63.6%, so the average value is 63.6% of the peak value. Okay. And the periodic time, so that's basically saying that the time that it's took for it to start and go from 0 up to that peak value on the positive side, down past 0 again, into the peak value on the negative side. Remember, AC current, like we said before, is going positive to negative, okay? It's crossing over that line of 0 all the time. So the time it takes for it to go to the peak value on positive, to cross the 0, go to the peak value negative, and back to 0 again, that distance is the periodic time. Okay, so frequency. So when we talk about frequency, let's go through that in a minute. Let's see what it's saying here. So if the periodic time of a signal is known, its frequency can be calculated using the equation that we're looking at here. Frequency equals 1 divided by the periodic time. Yeah? So we're looking at 1 divided by the periodic time. So if we draw it on here like this, so the time it takes for it to go from 0 up to the peak value on the positive side, past 0 again to the peak value on the negative side, and back to here again, that's the periodic time, isn't it? From there to there, okay? So if we come up here, and the frequency is how many times it does this per 1 second, okay? So that's the frequency. So the frequency is this here, what we just spoke about here. So we'll go through that again and again, don't worry. So you may be asked to calculate the periodic time. And let's have a look at that. So the periodic time is going to be 1 over the frequency. So it's going to be different. It's going to be down here. Let's draw this down here. So if we're asked to work out the frequency, yeah, what we're going to be putting for that is 1 over the periodic time. If we're asked to work out the periodic time, we're going to do the inverse of that. So we're going to do 1 over the frequency. Okay? So let's quick summary of sine waves then. Now I've done a chat about that. A sinusoidal waveform is used to represent one cycle of an alternating voltage or current. So remember what we said for that. That basically means the time it takes for it to go to cross to the peak value on the positive side, which would be there, cross through 0 again, into the negative side, reach the peak value on the negative side, and then back up to 0. So that's one cycle. And the coil in a simple electrical alternator rotates 360. That's what we represented before when we had that the 15-degree increments rotating round, and how that affects the sine wave, and whereabouts on, like for example, 90 degrees was here, wasn't it? 90 degrees was there when it was spinning round. This thing was spinning round. When it reached 90, it was at the peak value for the positive side. Okay, so the output voltage rises steadily from 0 volts to the peak value, and falls again to 0 volts, and then repeats the cycle in the opposite direction. So that's what we said, didn't we? We said that it goes, if we draw this line in here, it starts off at 0 volts, and it goes up to its peak value, crosses through 0 again, goes to its peak value at negative, and comes back up to 0 again. And that's one cycle. And then when it says opposite polarity, it means the polarity of this side is positive, because it's gone on the positive side up, and it's gone down into the negative side down here. So that would be the opposite polarity to each other. Opposite polarity. Okay. Okay, so let's just move on then. So periodic time for one cycle from 0 volts to 0 volts. That's the periodic time for one cycle. So the periodic time was this, wasn't it? From here all the way to when it reaches this side here. From 0 volts to 0 volts. Okay. So the frequency, sorry, this is all in the way here. Sorry, the frequency is the amount of full cycles in 1 second. So the frequency is the amount of full cycles in 1 second. Let's just rub all this out so we can see this, what we're seeing. Here we go. That's better. Right. So remember, the frequency was the amount of full cycles in 1 second. That's what it went through on the previous page, wasn't it? So the amount of times that this thing goes like this, back to there, that's one cycle. One cycle. So however many times it does that in 1 second, measured in hertz, that's going to be the frequency. And that's measured in 1 over the periodic time. Okay, let's move on to the next bit. So the peak value of voltage reached on either positive or negative side of the wave. right? So we went through that, didn't we? We spoke about how it's going to reach a peak on the positive side and a peak on the negative side as well. So we did that, and we can recap on that again and again if you like, or you can rewatch this video. So the peak to peak value was the total value between the positive and negative peak values. So if we remembered that as it goes, as our sine wave does this, so if we draw it out again, as our sine wave goes from 0, okay, and goes up to the peak value there, down to the peak value here. So this is the negative peak here, and this is the positive peak up here. So this here is the peak to peak value. Yeah, quite straightforward, isn't it? So peak up there to peak down here, that's the peak to peak value. And the peak value, which we just spoke about in the last one, would be this, wouldn't it? It'd be this, just on one side. So on the positive side, the peak value is from 0 to the positive peak. Okay, let's rub this out again quickly now so we can move on to this next bit. The last part now. So the RMS value was the peak value multiplied by 7.07. Okay, so we know that. And that's basically saying, isn't it, that the RMS equals 70.7% of the peak. Okay. And then the average value is equal to the peak multiplied by 0.636. So what we're saying there is that the average value, equals 63.6% of the peak value. Okay, and that's the same as multiplying by 0.636.